This is a video about central symmetry, and specifically it's about deciding if a shape has a center of symmetry. So here I have a selection of shapes. I have a rectangle, a triangle, more specifically an equilateral triangle, a parallelogram, and a trapezium. Of these, the trapezium is probably the one that you've encountered the least. And just to provide a brief definition of what a trapezium is, it's a quadrilateral which has two opposite sides that are parallel. And just before we get into central symmetry, I want to pose a question to you that I'll answer at the end of the video. I'd like to know how many trapeziums are in this image. And I'll tell you at the end of the video. But for the moment, back to the idea of identifying if a shape has a center of symmetry. There's one really quick and easy way to make this decision. It's simply a question of, if I turn the whole object through 180 degrees, will it look the same as it looks right now? So let's see what we mean. Let's take our rectangle. Let's turn it so that its top is at the bottom. I'm basically flipping it over. I'm turning it through 180 degrees. Yeah, it looks the exact same as it looked originally. So yes, my rectangle has a center of symmetry. Next, I look at my triangle. Okay, so if I turn my triangle through 180 degrees, is it going to look exactly the same as it does now? Okay, so the result that I have, it's still the same triangle, but it doesn't look the exact same as it looked originally. So this triangle does not have a center of symmetry. What about this equilateral triangle? It looks very symmetrical. Surely it has a center of symmetry. Well, to decide, all I have to do again is just take it and turn it through 180 degrees. Does it look exactly the same as it did starting out? No. Well, that means that equilateral triangle does not have a center of symmetry. What about this parallelogram? We discussed axes of symmetry in parallelograms previously, and we decided that a parallelogram didn't have an axis of symmetry. There wasn't a line I could fold it over on top of itself by. But does it have a center of symmetry? Well, again, let's just see if I turn it through 180, is it going to look exactly the same? Okay, so before we begin, let's just remind ourselves it's pointing out at the top. Okay, so let's turn it through 180 degrees. When I do that, still pointing out at the top. It looks the exact same as it did before. So yes, it has a center of symmetry. What about the trapezium? This trapezium, it looks like it does have an axis of symmetry, because I could fold it over on itself, but does it have a center of symmetry? So let's turn it through 180. Oh no, it doesn't look exactly as it did originally, so no, it doesn't have a center of symmetry. It's important to note here that just because a shape has an axis of symmetry does not automatically mean that it has a center of symmetry. Having an axis of symmetry does not automatically mean a shape will have a center of symmetry. And remember, the quick way to tell is to flip the shape over, and if it looks the exact same as it did originally, then it does have a center of symmetry. And if it does not look the exact same as it did originally, it does not have a center of symmetry. So flipping the shape is the trick in this case. Okay, to come back and answer my earlier question, you pointed out we had a trapezium in our diagram, okay, which was a quadrilateral, or four-sided shape, where two opposite sides are parallel. And I asked, how many trapeziums do you see on the screen right now? And the answer is that there are 3 trapeziums. How is that possible? Well, we obviously have this guy down here in the bottom right-hand corner. You might also spot that your parallelogram is actually a trapezium, because it definitely has 2 opposite sides that are parallel. In fact, it has more than that, but it only has to meet that description in order to be a trapezium. So it has more parallel sides, but it definitely has 2 opposite sides that are parallel, and it's a quadrilateral. So that parallelogram is a trapezium. So now can you spot the other one? It's our rectangle. Again, it actually exceeds the requirements for the trapezium because it has more than 2 parallel lines, but that's all it has to have to be a trapezium. It just has to have 2 opposite sides that are parallel. It has that, and it's a quadrilateral, so it's definitely a trapezium.